So today we're going to talk about wave motion, and we're going to start with an example of a wave. As a matter of fact, we're going to start with the wave. What I'm going to do is I'm going to move up and down. But in the multiple images, you saw I'm moving up and down. The wave moves this way. And so what's transmitted from frame to frame to frame is the motion. I'm moving up and down, but the wave is moving this way. And this is an example of a transverse wave. In the book, we'll see two different types of waves. There are transverse waves and there are longitudinal waves. In a transverse wave, the medium moves perpendicular to the direction of motion of the wave. For a longitudinal wave, the medium moves parallel to the motion of the wave. But in each case, the wave moves. The medium doesn't actually go anywhere. Now, we're going to use this wave machine to explore the properties of wave motion. So a wave is fundamentally a disturbance that propagates. So if I take the end of this rod and I shake it, there's a disturbance that moves down the rod. And if we trace it, we can watch the motion of the disturbance. And you can see that moves down the rod, and then it actually bounces and comes back. But we're going to look at the motion of the wave, the motion of the disturbance. But we're also going to consider the motion of the medium. And as we saw, there's two different types of waves. There's transverse, longitudinal waves. Think about this. Well, think about this wave motion as the motion of the tip of the rod. So think about the motion of the tip of the rod. When I shake a wave and it travels down the machine, is this a transverse or a longitudinal wave? Think about that. We'll give you some choices. So let's take a look. The rods, the tip of the rod moves up and down. The wave moves sideways. So this is a classic case of a transverse wave. The rods are moving this way. The wave is moving this way. And that's the first of the two types of waves that we look at in the chapter, the transverse wave. The other type is the longitudinal wave. So next up, we're going to look at sound waves. Look at the motion of the loudspeaker here. And actually, anytime you listen to a speaker, this is exactly what's happening inside. There's a cone which is moving back and forth like this. And as it moves forward, it compresses the air in front of it. And that compression is the disturbance that travels toward you. So the speaker cone is moving back and forth like this. And so this is a longitudinal wave because the wave is traveling toward you, but the motion is along the direction. So this is an example of a longitudinal wave. Now the speaker cone is moving back and forth. So it's sending out waves. It is, but you don't hear it. And the reason you don't hear it is because of the frequency with which it moves back and forth. Frequency is a term we saw before in chapter 14 when we talked about simple harmonic motion, but it's a term that also applies to waves. And the properties that we use to describe waves, frequency, wavelength, speed, is something we'll talk about in the next segment.